Okay, welcome. So now we're going to learn that there are specific kinds of chemical reactions. We're going to notice different patterns forming, and that's going to help us when we're trying to figure out products and when there's kind of mystery about what's going on. So chemical elements are seemingly going to bond in just certain predictable ways. And so the first kind of chemical reaction we have is called a synthesis reaction, sometimes known as a combination reaction. This is when two or more substances react and form a single new substance. So I've got this little diagram for you, our friend Mario. We've got his cart and Mario himself coming together to form a synthesis. So something like this would be called the synthesis reaction. Magnesium plus oxygen producing magnesium oxide. Notice it's balanced with coefficients. Notice we have phases. Okay, that's good. The opposite of a synthesis reaction would be called a decomposition reaction. A decomposition is when a single compound is going to break down into two or more simpler products. So we have Luigi on his cart, and then after the reaction, Luigi is separate from his cart, so it's breaking down. Notice that we have the same parts, they're just broken down. Okay? And there we have some actual chemical elements. Now we have something called a single replacement reaction. Okay, so let's talk about that. In a single replacement reaction, one element that is a single element replaces another element in a compound. So I like to call this the singleton. So the singleton is going to replace an element that's in a compound, which has been bonded. Both of the reactants and the products consist of one element and one compound. When metals replace metals, we call it a cationic single replacement, because remember, cations are positive. Metals would be positive, oxidation states. When nonmetals replace nonmetals, we call that anionic single replacement. Okay? This is not super important. I like to teach my honors class this. If you're just in the regular college prep, you might not ever see this again, and that's okay. But it is good to know. We also need to go to reference table J. So turn there right now. I will. Reference table J is called the activity series. Because sometimes these reactions aren't actually going to happen. Your free element, your singleton, must be more reactive than whoever it wants to replace. Check table J. Your free element must be higher on the list. So I'm not going to pull table J up on my screen. You can certainly go there. It's on page 5. Notice that we have two columns, metals and nonmetals. Most active is at the top, least active is on the bottom. The tricky part is, there's my picture. We'll get there in a second. On table J, hydrogen is considered a metal. It is not a metal. And in fact, at the bottom of table J, it reminds you of that. However, hydrogen acts like a metal because it likes to lose its electrons. So it acts like a metal. So they include hydrogen on the metal side, but it is not indeed a metal. So metals would want to replace other metals. Nonmetals would want to replace other nonmetals, but only if they are higher. And we'll see an example of that. So here's our Mario analogy. You see Wario, naughty, and Mario's on his cart. After the reaction, you see that Wario has the cart, and Mario does not. And that's because Wario must be higher on table J. So here we have an example. Now you can see that it actually happened. So zinc is a metal. So it's going to want to replace whoever is a metal in the compound. So that would be copper. Is zinc more active than copper? I look on table J and it is. Zinc is like about halfway down the list. Copper is third from the last. So because it's more active, it's going to be able to bump that out. Now my copper is alone. Zinc is in the compound. This would be called a cationic single replacement, if you wanted to be more specific. Now, let's just say, there's that. Let's say I had something like silver. Okay, so there's that. So let's say I had that. So then I look on table J, I see that silver is below copper on table J. That cannot happen. This reaction will not occur. So you can say does not react. You write those words. You don't write X. You don't write the same thing over. You say does not react, will not occur, something like that. Because since silver is less active than copper, nothing can happen. So be aware, table J is required for the single replacement and the single replacements only. All right. Now, if we have what we call a double replacement, that's going to be two replacements. The positive ions of two compounds are exchanged. The negative could be exchanged. It doesn't matter. It's like a do-si-do. So take a look here. We've got Yoshi on his green cart. We've got Toad on the blue cart. Notice on the right side, the product side, we have two switches. The riders switched their vehicles. So here we have chemical reaction with actual elements. So we have the calcium with the hydroxide, and now it's broken apart. It's over here, calcium's with the chlorine, and the chlorine is with the calcium now. It's called a double replacement. No need to check table J or any of that. It's simply for the single replacement. The last one we're going to talk about is called combustion. Combustion is when, this is kind of a long one, but it's okay. A hydrocarbon, now see how I have X and Y? That means some combination of carbons and hydrogens. Reacts with oxygen, often producing energy in the form of heat and light. Always produces carbon dioxide and water as your products. So that's kind of a trick to figure out if it's combustion. If it's combustion, you're going to give off carbon dioxide and water. So think of your car's engine, unless you have an electric engine. You're going to put your fossil fuel in here. This is methane in this case, but you would put that in your engine. You would need oxygen, and carbon dioxide would be given off, and water, the dripping from the tailpipe. Now, since you know those kinds of chemical reactions, you can predict the products. Excuse me. First thing you know, it's got to contain the same elements and the same number of atoms on both sides. Has to. So you're limited there. All right, so take a look. Calcium fluoride and iron, Roman numeral 2, nitrate. Okay. What kind of chemical reaction is this of our 5 reaction types? It can't be a decomposition because it's 2 different things, not one thing breaking down. It can't be a single replacement because I don't see any singletons. It's too complex to be a combination or synthesis. It's not going to be a combustion because I don't see a hydrocarbon reacting with oxygen. So it has to be a double replacement. So here's what I do. I figure out who's positive, who's negative, who's positive, who's negative. Okay? So on the product side, I say calcium now has to be with nitrate. But before I move on, I need to go to reference table, periodic table, and table E to figure out what the actual charges are. Because actually, this is calcium is a +2. Nitrate is a -1. So I must balance correctly. And I can get rid of those. And then the iron, which is +2, and I know that because it's from there. And that is going to now be with the fluorine. So there it would be like that. Excuse me. Now that each individual compound is balanced, I would go back and I would do my scorecard. Calcium is a 1, fluorine is a 2, iron is a 1. Now, I don't know. Sometimes you can keep the polyatomics together. I'll do it that way. Calcium 1, F2, iron 1, nitrate 2. Okay, so we are balanced like this. And I'm sorry that's messy. I don't have the pro version I can't erase. All right. All I have is one compound. So if all I have is one compound that's going to be breaking down, I just separate it out. Now, why is that F2? Diatomic by itself. And I don't even need to draw a scorecard, I know. Oh, let's go back. Did I say what this was? Yeah, this is a double replacement, 2 replacements. This is a decomposition because you see one item breaking down. These are 2 small, pretty simple things coming together So I have S, C, and Br. Now wait, don't bring that 2 over just yet. I got to open up my periodic table. Scandium is a +3, bromine is a -1, so when I crisscross, I get that. Get rid of that. All right, now I do my scorecard, which again, if you don't need your scorecard at this point, great. I see my bromines are not balanced. I see that we're going to have an odd combo, so I need to find my least common multiple, so I'll put a 3 here. And then I'll put a 2 here. That'll change the scandiums. That'll change this to a 6. Go back over here. Sorry. This is called a synthesis reaction coming together. All right. Now, don't get confused. This looks like it would be a synthesis, but actually this is a very specific kind. We've got a hydrocarbon and oxygen. So this is a combustion. Okay. So combustions can be challenging to balance, especially the higher ones. Okay. We gotta figure out. Put me on the spot here. I should have done this in advance. We need an even number of oxygens, but I'll do that last. What about carbons? Hydrogens need to be 10. I'm going to guess. It's not going to work for my oxygen. Well, maybe. I'm going to leave this just for the sake of time. This is unbalanced. Figure it out. Okay? All right, zinc and hydrochloric acid. So I see a singleton and a compound. So I need to go to reference table J because this is a single replacement. Now, when I go to table J, I see that zinc is a metal. Hydrogen is not technically a metal, but it's going to act as one. So this would be our cationic single replacement. Is zinc higher than hydrogen? Yes. So it bumps out hydrogen. Okay, a couple things. First of all, hydrogen's by itself, so it's got to be H2. Second of all, how did I know zinc had to be first? Well, metals come first. Positives come first. And also, oops, that's not necessarily balanced. Zinc is a +2. Chlorine's a -1. Crisscross to get that. And then I just see it. You got to do that. Okay. Zinc and magnesium chloride. So we've got zinc. Zinc, is it higher than magnesium? No, it is not. So you say no reaction because zinc is less active than magnesium. Don't write anything else. Just say no reaction. By the way, reaction can be abbreviated RXN. I don't know if I've mentioned that yet. Okay. Thanks for watching. Please reach out if you've got questions.